All right. Well, I'll just quickly go over some of these PRs then. Adam, maybe you can get started on your stuff after that. Um, all right. There's two new ones here. The first one is kind of interesting. It's pulling ePull events from user space rather than the kernel, and he's seeing a reasonably decent performance improvement from it in the async messenger. So um, that sounds good to me. I kind of looked through the code and realized I don't really know ePull that well. So if anyone does,
What's the change?
uh, pulling ePull events from user space. So that commit here, I'll link it in chat. There it is. And let's see, we've got so basically instead of ePull create, he's got this other thing. We'll create two that he made. And instead of calling ePull wait, it's this like user space ePull wait.
I see. Yeah, Kane is small, but real.
Yeah. And I don't know enough about like the ePull code to know like if what he's doing here exactly makes sense, I guess. I mean it seems to. I guess it works, right? But
Well, it'll become more pull intensive, but it'll be looking at whatever's in the user address space gets updated infrequently, whatever.
I was mostly excited that he includes performance tests in his PRs. It's very exciting for me. All right, so that's new. If anyone wants to look at it and give their thumbs up or not, obviously it needs to go through testing. Um, but I don't know, sounds good to me. Um, there's this other one for optimized check UTF-8, which is apparently something. This I think this is one of the like someone that contributed to C Star and then added the same thing for us. So um, yeah, I mean, seems fine to me. Who's reviewing it though? So it should be good. Um, two PRs closed. Both were librd stuff. One was this dispatch delayed requests only if read intersects. Jason reviewed that, and then the other one was this librd new default write around cache policy. And apparently, the issues that were there previously must have gotten fixed. Um, and that's exciting. That's good news. I'm very curious to see how that does. And then two that were updated, the new IO Uring IO engine. Uh, I think I may try to take a test drive on that time soon. I really want to see how that does on real hardware, not just on RAM drive. So I may run some tests on that. And then Sam reviewed this EC Stripe Cache PR. I think he had maybe done some things similar at one point, but he definitely is the right person to look at that. Um, there were a couple other ones in here that didn't see much movement. Yeah, uh, just related to this MDS cache memory limit one. Where we had a meeting earlier this week to talk about the priority cache manager and kind of explain how that works. That got merged too earlier this week. So work should now start up on doing like memory auto tuning for the other daemons. I think maybe the Mon is actually going to get it first, but potentially the Mon, the MDS, maybe RGW. I don't know if it's worthwhile there or not, but at least for the Mon and MDS, I think there's work planned.
Which for RGW?
Auto tuning of cache sizes to keep the
okay.
daemon within a certain memory envelope. Not sure if that actually makes sense for RGW or not, but the other daemons are, I think, going to get it. Ooh. All right. Well, I think that's it for pull requests. Adam, do you want to take over and talk about your sharding work?
Yes, this will be actually combined sharding work and TRoxDB. Some hints of that also in that testing table. But basically, the work was about to test if we can get some better performance from splitting column our RocksDB database in BlueStore into multiple column families. And to go just straight to the point, this will be a row 80 in the first stats sheet. And here are some configurations in the columns, configurations for how many columns are prepared and how large is a write-ahead log for each column. And definitely there is consistent improvements for performance, although small, like a maximum is for 4.29% improvement in IOPS. And this, I'm sure, is not like a testing fluke. It's quite consistent about with reruns in different scenarios. But what is a bit important here, each iteration, to obtain each performance sample, you can see like in the first column, like from row 38 to 42, there are performed 4 runs of the same test before actually sampling performance, because I noticed, which is not surprising, that I have to mature a cluster a bit to get some reliable measurements. And actually, the tests are performed in batches. Mean first run is performed on all the tests, and then second run on all tests, and so on. So it's not the execution sequence of the test. It's not like here from up to down, but you should go like run 1 test 4K writes, then run 1 test mixed writes, and run 1 tests only writes. So this and as you can see, it's quite fast, reaching some values, some convergence to some reasonable value. So that's about methodology.
Adam, can I ask what is the like the 3-prim? What is that?
You can look row 25 are split for parameters for column families and write ahead log. So 3 prim means each column had 128 megabytes for write ahead log, which of course means that there's also a note to say that for each column family requires its own write ahead log, and it's totally separated from other ones. And you can see here that objects are split into 13 shards, and OMAPs are split into 17 shards, and so on, so on. And not often used prefixes like superblock, allocator statistics are just merged to 0 means are matched to default column family.
What are the two T-Rocks examples? Are they reliable, or or do they reflect experimentation with a T-Rocks that's not fully integrated as yesterday?
I don't believe them. They of course show some real numbers, but I'm not 100% sure if actually that feature in T-Rocks DB, splitting keys and values, was enabled. The last test, which has not finished, well, I made a modification that, looking at the code, that convinced me that may be a test when I finally got that feature on. But I'm waiting confirmation from Remington Mr. Remington, if that's the way, because it's never nowhere. Maybe it's stated somewhere. I wasn't able to actually find a manual how to enable this feature for column family, or if you have one, just for all the database. It's just my reading from code. But it tends up a bit, it gives even more numbers. I mean, the -100% in each column is a result that only last value is used as reference, so there is nothing. I mean, yeah. So okay, so that's the row above. This is IOPS per second. IOPS, okay, operations per second. And there's also other table which measures. It starts at row 87, which measures how much more CPU we consumed to actually do that work. This is obtained by just perf statting OSD, entire OSD, but only OSD process. I mean, each OSD separately, of course. And unlike, I mean, maybe that's not very surprisingly, but for me actually it was. It seems that we just still eat more CPU to provide more IOPS. I just thought that maybe if we have a nicer structure of column families, we will be more CPU efficient with the work we perform. But it's worth noting that test case 4, which had a larger write-ahead log for each column family, and having less column families, respectively 6 and 8, with on the most hot path, actually gave some real improvement, 2.5%, with minimal, I mean, relatively minimal additional burden for OSD.
Mm-hmm.
It's in a lot of the testing I've done, having larger write ahead log buffers usually means that we see less write amplification in the during compaction. I suspect probably because we're getting the tombstones for PG log updates landing within the same buffer. and so before it ever makes it into level 0, it can just be eradicated.
which
I
is
wonder if,
great. So yeah, sort of our key move here until we can fix that or change that.
yeah,
Which of course means that I might be able to set specifically larger write ahead log for different column families, and maybe that way also use this.
yeah. I was thinking about that too, that if we have pglog in one that has its own buffer sizes, we might be able to go with smaller ones for like onode.
Well, Mark, if you had some, I mean, maybe I will. If you had some ideas how to more finely set this write ahead log for separate column families, because currently I just set it the same value for all of them, and now I mean just only now I'm not thinking that maybe that was not a so huge idea.
I don't know. I honestly, I haven't even tried any of this kind of stuff yet with like separate column family write ahead logs. Just in the other stuff that I was working on earlier this week, I just started looking at different like cache block caches for different column families, and that ended up helping a lot. But that's unrelated to your stuff, I think.
Yeah, I mean, I think I will try to find some configuration of BlueStore sharding that will maybe maximize performance. But if you guys have some hints how it may impact, because I'm actually clueless here. I made that code, and because I make a measurement just from a very high that details why specific change gives a boost is totally obscured from me.
I think
I tried to get a perf analysis on that, but it seems that each case and each test case and each setting sometimes varies very much from the point where it's the most CPU intense. So that makes it difficult to actually pinpoint linear dependency on settings.
what I think would be really interesting to see with your code is if you did use Rados Bench or something, whatever, it doesn't matter, to do a bunch of small OMAP writes. So do like, 4K or I don't know, whatever you want, but just lots and lots of small OMAP writes. You fill it up with like 512 gigabytes worth, and then watch the compaction stats in the OSD log or whatever, however you're looking at compaction information, and see if like level 3 compactions are happening. Well, in your case with sharding, you might even see level 3 compactions. Maybe it's just level 2, but see if there's a difference in how much time you're spending in compaction between the two.
Well, sure, I can. I mean, that's easy one to do. I have a test for OMAPs there, and I can just bump up amount of OMAP settings there, and that will be no problem.
Cool. I still wonder if the biggest advantage of doing something like this would be to have like kind of parallel level hierarchies, where instead of doing having tons of data in level 3 where you have high rate amplification and long compactions, if now you've got more data in level 2, multiple level 2s, and maybe those compactions don't take as long. Matt, I think on customers sometimes or users we've seen like for RGW like long compactions in practice, if I remember right.
Yes. Well, certainly certainly in workflows that have a substantial component of deletes. than compaction. I don't know what to say long compactions, but yes, basically compaction tends to not and ends up dominating workload, and it is with large and it is frequently the case that that it's usually it has frequently and it continued to the present led to OSDs misbehaving.
Yeah, I think kind of understanding if sharding helps at all for that, and if TRoxDB helps at all for that. Those are kind of the
It sounds like T-Rox. I mean, this is a question for Adam, but we only had a couple days. But it sounds like it sounds like the interactions with Remington was a little bizarre. I get the feeling that we haven't gotten a good. We haven't the engagement with T-Rox is still just kind of starting where it isn't. So we shouldn't trust the evaluation yet, or do you feel differently, Adam?
The code is really good. I mean, it's really well structured, and it seems to be good quality. But
I mean, do you feel like we've measured what we're supposed to be measuring at this stage from it? Sound like
I think I will be able to measure its performance difference, but the unknown for me is how much extra space it will require when doing compaction from after this change. Maybe
Why do we expect it would require more space?
Yeah, I know that in real life our clusters require extra space to actually perform compaction.
Well,
so I also expect that from this variant.
Shouldn't it require less because we're moving only pointers?
But on the intermediate step, we still have to create new table on new level with a data. So
do we? I thought we'd have to create a new table with just the indirects.
Well, I read on original RocksDB about the leveled compaction algorithms, and it seemed that often they need to go in the deeper levels with moving keys, and then they are able to just go back and clear that unnecessary entire tables. So I have no idea if the cross-table reference on values will be available for this modification. So maybe they will still have to copy the values to the next table also.
I see.
But I'm just.
Right.
I don't know. I'm just trying to find out algorithm which I have not looked specifically into.
Yeah, and I'm only sort of borrowing from for the analysis in the Apache Duso work, right? That that dealt with LevelDB rather than RocksDB, what basically sounds like the cognitive improvement, cognitive change in LevelDB yielded a lot less data movement and it yielded speed ups also. They're not claiming speed ups, but they're claiming data loss or extraction and data movement. So I'm not quite sure how that works, at least in the T-Rex report that they sent us initially. So yeah, I'm just looking to learn more about it. There's one of the few. It seems to be in the same direction as one of the few sort of scientifically validated improvements to this class of system.
Well, I actually a bit expected speed up if I thought that maybe having separate keys and values will allow me to traverse much less space where trying to find actual key.
Yeah.
So on that level, I was hoping really for speed up also.
Agreed. Okay. Well, I look forward to I think it's valuable that you're digging at it and learning what's going on. I mean, I think it sounds like it's early enough days with it that's going to take some discovery.
Well, the really good part is that after fixing the compilation, which I'm actually amazed why somebody that made so good code actually left defines in class members. And that was a bit mysterious for me. But after I made a change to that, it really works without hiccups. So maybe it was even used somewhere. It definitely looks so. It's too good to be just completed right of that and be so mature.
So, well, which seems like it suggests that there must be some benefit from it for some, and somehow, if true, what one hopes. Okay.
I'm still hoping that we'll see it in compaction.
So yeah, once we have more information, if you have you not yet done a kind of a saturation workload that's intended to promote compaction? So I'm not quite sure what that looks like, but I mean, in RHW from Cosbench perspective, it involves things that writing a lot of objects, deleting a lot of objects, and rewriting them, and other things.
Yep, my tests are like forcing tens of thousands of compactions. So it's.
So we should be seeing that. We should be seeing a lot of results. Okay.
Yep, I mean the only problem might be that I'm not capturing all logs and all data that might be useful. So I will have to rerun some tests to obtain real information. But on that stage, my path, I think, will be to ask Remington Braxa to provide some configuration for column families or any other settings that he thinks are most important. Yeah.
I want to say too that performance may not actually be the thing that really matters here, right? Like it's nice if we get performance gain, but the bigger improvement might be that if there's less write amplification on the flash device, it may improve how long the device lasts for users. Even if it doesn't make it faster, if the device is fast enough, it can just absorb the writes and at the same speed. Just having it do less work might be really important to make their hardware last.
Well, that's what their paper original proposal claimed, and that seems perfectly sane. But it's useful only to a. Its value to us if it stops there is somewhat in doubt.
I might have done usual thing. I had a tool set to measure performance, so I measured what I already have instead of doing what I should.
Well, for someone with certain kinds of flash, obviously cares a whole lot about that, and maybe that's relevant, but but it isn't as valuable as speeding things as speeding up compactions for at least for the users for the challenges we have, or at least in RHW with large OMAP.
Matt, I have seen recently a number of system architectures that users have ended up with that are using, one or if we're lucky, 3 drive write per day drives for the Debian wall, which it frightens me honestly. I mean, I'd be much more comfortable with at least 10, but it seems to be a real thing that people are using kind of low endurance drives for these high endurance cases.
Well, it's not going to yield a satisfying result for most of them. I
agree, but anything that we can do to maybe lessen the pain would be
no. I mean, if it's a degree that it makes sense. I mean, for some deployment, it could be hugely beneficial, and if it doesn't drop off performance, I assume it'll be part of some solution, but. Got more to achieve.
Yeah.
What about, I mean, more broadly, do you ever see in any testing that we do and this goes to the workload top point you just raised in terms of forcing compaction and so on. What we see in the worst case scenarios, where we have we have sometimes it's been because of sometimes it's been in response to issues in RGW that shouldn't really have been there. Like for example, if we did when we weren't proper, if there have been bugs where we didn't properly clean up all the key sequences that were involved in multi-site synchronization, data log, and so forth. So you get a very large expansion of OMAP key space, and then later we try to delete it, compact, and so in other words, in various real workloads, we get operation compactions taking so long that OSDs time out, and sort of tangential to the simple performance topic, we'd like to make progress on making OSDs resilient so that sort of thing doesn't happen.
Yeah.
And I wondered if you'd found workloads that expose that and allow us to work on how to make the system, the subsystem at large, degrade gracefully rather than flap.
So the workloads that I've seen are slowest have, like you said, Matt, been like RGW deletes. Those suck. But on our hardware on Incerta, like our kind of community test hardware, our everything is fast enough that the OSDs very, very rarely ever time out. I don't think I've actually seen them time out from a performance workload maybe in a very long time. In the early days, like New Store, Blue Store, we could do it, but that was when we had like really crappy code in some areas. I have not seen anything on Incerta timeout.
For example, there were apparently Vicky and Umrao could discuss. But we had an incident last week where a downstream Luminous-based Blue Store environment with some odd Roxy tunings apparently, or at least did this.
Hardware was it on?
I can find it all for you, but it's a 13 OSD cluster with something or other. But I don't have it in my mind what exactly it is.
I wouldn't be surprised, especially if you were on drives that did not handle the workload very well. That you could force it, right?
But so we can maybe circle back to this. Maybe we could have a discussion about like cross-examining some of the hardware, those the bombs for that, and see what we learn from that.
Sure, that'd be fine.
I know something like about adaptive throttles to me, or rather adaptive. It sounds like more of a discussion about adaptive timeouts. The timeouts are deliberately stupid, right? There's nothing clever about them. It's just a way of detecting that the drive has gone out to lunch and it's not coming back. So if they're showing up in cases where the OSD isn't dead, multiply the timeouts by 10.
Sure.
They're not there for any purpose other than detecting death. That's the only reason.
So I think we do that, but this is where this is the thing I leave, and I don't want to get into a rat hole. But yeah, it'd be helpful to think about this, and if they should just be ginormous, then we should just make it so that they are by default, I guess, almost infinite. But if that doesn't make sense, then maybe there's some need for.
Well, and we have blocking in all kinds of places in the stack, right? Even at the libIO level, right? IO submit can block. You can be blocking on IO submit for seconds, which in a scenario where you have a 15-second timeout, that's not good. So it might be that the more we get rid of stuff like that, going over to URing, going over to more asynchronous models, maybe that problem kind of slowly fades away. I don't know.
Worst case scenarios are definitely ones where it's possible to produce cases where we start deleting OMAP keys and it yields quickly a primary OSD failing out, and there's a cascading failure.
When you're doing those deletes, is it just that it's taking lots and lots of time for the OSD to respond? Is that usually what you're seeing?
Well, I mean, usually, usually is what the DSS will describe it as an OSD is flapped, so it gets marked out.
Okay. Yeah, we may need to try to reconstruct exactly what's going on there.
I don't think that part's that complicated. If you're submitting enough deletes to RocksDB, eventually operations that should be fast will block on the progress of compaction, which will turn a brief operation to a long operation. If this happens in a way that is fairly uniform across the OSDs, they will all pretty much die at the same time. Like, I mean, that part's not mysterious. The part
yeah, exactly. It's not mysterious, but I guess logically, it's not.
I know. Yeah.
It can never be. All I'm saying is it can never be better to fail to then fail to the secondary, right? It can never be better.
I agree. What I'm saying is it shouldn't be timing out.
Agreed. Okay. I think
yeah,
we're agreeing.
Is it definitely that though, or is it?
Yeah, it's. I mean, I've seen that. You don't see that.
Well, okay, yeah, but beyond that, could it also be time spent iterating over tombstones?
Yeah, no, that's exactly what it is. That's what I'm saying.
Okay.
It doesn't matter what the actual cause is. The purpose of the timeout is to run a very coarse grain. Something took a long time until.
I mean, the point is that we should only be marking an OSD out if it actually is if it actually would be better for another OSD to take over.
Right. So it seems like there are sort of two basic things. One, advise the customer to increase the timeouts by a factor of 100 or whatever if you see this. And two, if as we do this sort of throttle thing where we start getting a feel for how long Bluestore actually takes to do things, it might make sense to feed that back into the timeouts as well. That way we know it's not just whatever was configured, it's 100 or 1,000 times the average operation length, something like that. That might be the way to fix it in a more real sense. But for now, the right way is to simply know that we need to sometimes increase the timeouts by a lot.
Yeah, and it's totally dependent on hardware. We can't guess how long it's going to take. That's been our problem for so many things, though.
Yeah, but I mean, what you want to know, isn't it? What you want to know whether or not the shift in late whatever the new behavior, the current observed behavior is responding in a natural way to the workload for the hardware that we essentially rather than as opposed to that it's like there ought to be some way to perhaps infer that.
Maybe getting back to Adam's whole testing that he's doing here is, kind of, at least in my mind, the whole kind of purpose for a lot of this was just to reduce the amount of time in compaction. So, in parallel to increasing timeouts, it's, avoiding these super, super long compactions, right?
I would happy if I could get some algorithm generator to get a data that can simulate that huge work that you, Matt, mentioned, because I didn't really grasp what specifics are there that are causing so.
Yeah. Well, one example, there have been more than one, but one not naturalistic one necessarily that that we've had. We produce we are currently relying on OMAP to generate to communicate a bunch of replication related events, and the expectation is that we're going to be continually retiring events, while new ones are being produced. One pathological case is if we allow far too many to build up in a specific OMAP key sequence, key range for an object range. and then we try to delete a bunch at once. Doing cleanup, that has frequently been an easy way to produce the misbehavior. And then so a throttling key deletion becomes a way to sneak, to get through it. But in effect, the OSD should have throttled itself to that point and just degraded slowly, and instead it knocks itself out.
So you postulate that this is just a sheer amount of keys that are deleted at once that cause this, or there is some.
Well, to the best of my knowledge, that's a way to produce some behavior that we have seen in the past. And it goes back, we've seen this recently, as some, as this year. It has been a way. If there are two, it's almost always, well, when we didn't have data log trimming, then the data log segments, for all the OMAP, for all the data log shards on a particular OSD got extraordinarily long. The keys are all clustered because they're all for the same objects. And then we tried to rapidly delete them naively. When using Rails commands typically, it can provide, that has been a simple case that reproduces.
Yeah, I will try to do something like that. Just how many thousands are required? 10, 20, 100?
Think millions.
Millions?
All right. Have we beaten that topic enough to death, or should any other?
Sorry.
Oh no, it's okay. I'm fine.
Me to death at times, but
yeah, just a real quick question on that. I'm actually dealing with a S3 workload right now that's taking far longer, doing lots of deletes than it should. And I haven't looked at compaction time significantly. What would you guys consider to be reasonable quantities of compactions and compaction times when we're looking at a system? And I'm looking at one right here that's over a second in length.
I have seen ones that have taken 20 seconds.
Okay.
That's not good, obviously. And a second in length is still maybe be concerning. What do you remember? What level of compaction that was?
Let me look. I've actually got the log in front of me right now. Level 1.
Yeah. So the really long ones I've seen have usually been in like level 3. The higher you go, the more ramp there is, and the longer the whole thing takes, more data and write amp. This I just linked. This is a tool that I wrote a while back that will look through the events, the compaction events, and then you can kind of like look at it on a per level basis or look at the overall stats. There's like, I think, a summary flag or something in there that you can say. But it'll give you a bunch of data about kind of the aggregate statistics that
Awesome.
may be useful.
Absolutely. Thanks.
Cool. Yeah, if you see anything real odd looking, like horribly long ones at high levels, let me know. It's good information to have.
Yeah, definitely will do.
Cool. All right. Well, Adam, if you don't mind, I would want to maybe talk about the cache work I did. Or is there anything else for the T-Rocks or sharding?
No.
All right. Well, then quickly here, I'll mention that last week I think I talked a little bit about a long-standing problem we've had in BlueStore where we double cache onodes, both in the BlueStore onode cache and also in the RocksDB block cache. they're represented in different ways, but the overall data is basically the same. So what that means is that when we get into a situation where we don't have data cached, we don't have the onode cached, it will read it from the SST file, RocksDB will load that block into the block cache, and then also it will get read into the BlueStore onode cache. And when you're not doing that, if you've never had to read anything off disk, it's great. You end up only really having data in the onode cache. But as soon as you start reading from disk, everything kind of falls apart and performance can go down pretty dramatically. So what I did last week, actually on Friday, I wrote basically code that will take and use the column families a column family by default for the KV data. We already had that built in already, but then we'll create a separate block cache for that particular column family that's limited in size using the same priority cache interface that our other BlueStore caches use now, and then that will be treated independently of the rest of the RocksDB block cache, which has like OMAP entries and other things in it. And so over the weekend, I ended up running some tests on it, and it turned out pretty good. It has the biggest effect when you have kind of around our standard OSD memory target settings, maybe 3 to 6 gigabytes of an OSD memory target. That translates into like between maybe 2 and 4.5 gigabytes of cache to split between all of our caches. And yeah, with different data set sizes, once you get big enough, it has a fairly substantial effect, up maybe a 25% improvement for small random write workloads. So basically, small random write workloads against a large data set is where this kind of really helps, especially if you have enough cache that you can see a big difference when not doing the double caching. So that's really it. I've got a branch, but not a PR yet. Although now that we've merged the priority cache manager, I should be able to make one fairly quickly. So that's basically it. Any questions or comments on that? All right. Well then, anyone have anything they want to bring up this week that we didn't cover? All right then. Well, have a good week, everyone, and we'll meet again next week.
Thanks.
See you guys.